Diesel and gasoline engines operate on fundamentally different principles. Understanding these differences is crucial to comprehending why gasoline damages diesel engines. Diesel engines use compression ignition with compression ratios between 14 to 1 and 23 to 1. The fuel ignites from heat generated by high compression alone without spark plugs. Gasoline engines use spark ignition with lower compression ratios of 8 to 1 to 12 to 1. They require spark plugs to ignite the fuel-air mixture. The chemical properties of diesel and gasoline are dramatically different. These differences explain why gasoline causes immediate damage in diesel systems. Gasoline has a much lower flash point than diesel fuel. This means gasoline ignites at lower temperatures, causing premature ignition in diesel engines designed for higher ignition temperatures. More critically, diesel fuel acts as a lubricant for fuel injection system components. Gasoline completely lacks these lubricating properties, leading to immediate friction and wear damage. When gasoline enters a diesel engine, several immediate combustion problems occur that are visible and audible to the operator. These symptoms occur because gasoline's lower ignition temperature causes it to ignite too early in the compression cycle, disrupting the engine's carefully timed combustion process. The lack of lubrication in gasoline causes immediate and severe damage to diesel fuel system components, which are designed to operate with diesel's natural lubricating properties. Modern diesel engines with high-precision fuel injection systems are particularly vulnerable. These systems operate at pressures up to 2,500 bar and have tighter manufacturing tolerances than older engines. The combination of wrong ignition timing, lack of lubrication, and high-pressure operation creates a cascade of damage that can destroy expensive fuel system components within hours of operation. If gasoline has been put into a diesel engine, immediate action is critical. The most important rule is do not start the engine under any circumstances. The repair process involves 4 essential steps. First, completely drain the fuel tank to remove all contaminated fuel. Second, replace all fuel filters in the system. Third, flush all fuel lines to remove any remaining contaminated fuel. Finally, inspect the fuel pump, as it may require replacement due to lack of lubrication from gasoline. Professional fuel filter replacement is often necessary. Here we see the typical process of replacing a diesel fuel filter, which is a critical component in the repair procedure. Repair costs vary dramatically based on how quickly the problem is addressed. If the engine was never started, costs range from $500 to $1,500. If the engine ran briefly, costs increase to $3,000 to $8,000. Extended operation can result in catastrophic damage costing $10,000 to $25,000 or more. Prevention is far more cost-effective than repair. The first strategy is visual verification. Always check the fuel type before pumping. Look for clear diesel fuel-only signs at the pump. Additional prevention methods include clearly labeling your fuel cap, educating all drivers who use the vehicle, and maintaining your fuel system regularly to ensure optimal performance. It's crucial to understand that most manufacturers do not cover misfueling incidents under warranty. Standard insurance policies typically exclude this type of damage, making prevention the most economical approach. Remember, immediate recognition and proper response can save thousands of dollars in repair costs. When in doubt, contact a professional immediately rather than attempting to start the engine.